Hello students, how are you? Hope you are doing well with Aptdemy's course material in our portal. You are working out our problem sheets. So based on your feedback, today we are going to discuss two problems on parabola. I hope if you follow the class, you will understand many things and that you will highly benefited after solving these two problems. Let us see what are the problems. Okay. At any point P on the parabola, let me select the pen. So, at any point P on the parabola equation is using y square minus 2y minus 4x plus 5 equal to 0. A tangent is drawn which gives the directrix at Q. Find the locus of point R which divides QP externally in the ratio half is to 1. Okay. So see the equation given is what? Y square minus 2y minus 4x plus 5 equal to 0. So I can write, it is not a standard parabola equation because we discussed in our regular classes y square equal to plus minus 4x or x square equal to plus minus 4y. They are the standard parabolic equation. But here, let us see what does this equation represent. So I can write this as y minus 1 whole square. So y square minus 2y plus 1, I make a minus 1 to adjust. Then there is minus 4x plus 5 equal to 0. So y minus 1 whole square is equal to 4x. Here it is plus 4, so 4x minus 4. So 4x minus 1. So y minus 1 whole square is equal to 4x minus 1. So this equation, from given equation, I arrived at this equation. Now look at this equation. This is equation of parabola, but you see this equation indicates that the curve passes through one. And you see, if you draw this coordinate axis, this is x-axis, this is y-axis, this is x dashed, this is y dashed. Okay, so this is y dashed. Okay, now consider two lines, x equal to 1 and y equal to 1. Just try to follow what I am doing. So this is y equal to 1 line and another line to take. This is x equal to 1 line. So what is the coordinate of this point? It is x equal to 1, y equal to 1, so it is 1, 1. Okay. Now, if I write y equal to y minus 1, capital Y is equal to y minus 1 and capital X equal to x minus 1, then this equation takes which form? It is y square equal to 4x. So, if y minus 1 equal to 0, this line represents, this is y minus 1 equal to 0. So, if I take this line, horizontal line, as y equal to 0 and this line as x equal to 0, then with respect to capital X, capital Y coordinate system, this represents a parabola like this. Okay, try to follow. This is a parabola. Okay, see, for this coordinate system, this is y-axis, x equal to 0, and this is x-axis, capital X-axis. With respect to this, the equation looks like this: capital Y square equal to 4 capital X. So this is a standard form, y square equal to 4x. So what I can make out from this equation? So with little coordinate transformation, from this equation we can get this equation, which is the standard equation of parabola, and you understand that it is passing through x equal to 0, y equal to 0, because this 0 point satisfies this equation. So with respect to this dotted coordinate system means this line and this line. The parabola looks like this. So from this equation, you just write y minus 1 is actually square root of 4x minus 1, and with a plus minus sign. I can write y minus 1 whole square equal to 4x minus 1. So y minus 1 is plus minus root over 4x minus 1. Again, I am writing y minus 1 is equal to plus minus root over 4x minus 1. So y is equal to 1 plus minus 4x minus 1. So the curve represented by this equation, which is a parabola, it is symmetrical about y equal to 1. Because for a given value of x, if you plug in any value of x, you get two values of y. One is y plus square root of 4x minus 1, another is y equal to 1 minus square root of 4x minus 1. So the curve is, I can readily write, curve is symmetrical about y equal to 1. So y equal to 1, this line. So curve is symmetrical about y equal to 1 line. And moreover, the curve is passing through one, because you just plug in x equal to 1, this side is 0, and y equal to 1, this side is 0. So curve is satisfied by the point 1 1. So 1 1 in the xy coordinate system, small xy coordinate system, is definitely a point on that, and it happens to be the vertex of the parabola. So the parabola, this is a parabola which is symmetrical about y equal to 1 line. It has a vertex at 1 1, and by little coordinate transformation, I could check that the parabola looks like this. With respect to the capital Y, capital X coordinate system, the parabola looks like, equation looks like this. And another interesting thing is that this parabola has a focal length A is equal to 1. because y square equal to 4ax is the standard equation where a is the focal length. So here a is 1 because 4 into 1 into x. So focal length is a equal to 1. Okay. So if this is the vertex, another interesting thing is that if x is less than 1, if x is less than 1 in this equation, then RHS becomes a negative quantity. So y minus 1 whole square is a negative quantity. That means y minus 1 is an imaginary thing. So the curve has no, curve means parabola, has no existence for x less than 1. If x is less than 1, I have seen that y minus 1 whole square is a negative quantity. That means y is imaginary. So from this drawing also you see for x, this is x equal to 1. Right to x equal to 1, there is the existence of parabola. Left to x equal to 1, when x is less than 1, there is no existence of parabola. So we have discussed how we can draw the graph for this equation. So it looks like this. Okay, so I think up to this there is no doubt. So once you are given an equation like this, how the plot will look like, that you can make out. Okay, now let us.
Actually, sir, one question is that you have mentioned is the parabola has no existence in case of x less than 1. But x less than 1 can be in between this now.
This region.
Yes.
Yeah, so there is no curve. So curve is like this.
So vertex is 1.1.
1. Vertex is 1. Be left to this. There is no. So just we have discussed in a regular class also that parabola has no existence in this side. Why? Because had we got y minus 1 whole square positive quantity, then we can get some real values of y. But here it becomes what? Y minus 1 whole square is a negative quantity. So it is imaginary. In the real plane, there is no existence of parabola in this. So parabola will be totally confined right to this line. And this line's equation is what? X equals to 1. Because all points in this line, x coordinate is 1. Okay. Is it okay? Up to this? So for such problems, first most important thing is to draw correctly the graph. Okay, so this is the vertex, this is the axis. So if I just list down what we got so far from the given equation. So this is the equation of the parabola. So this is the equation of the parabola, and what we got, vertex of the parabola with respect to the xy coordinate system is 1, 1. Okay, so vertex is at 1, 1, and what else you got? Axis of the parabola. This is the axis of the parabola, which is actually y equal to 1. So let me list down this, whatever we have got so far. So vertex of the parabola call this point A. Okay. Axis of the parabola is a line which is small y equal to 1. Focal length of the parabola we have already discussed. Focal length of the parabola is equal to 1. Now focal length 1 means where is the focus? So focal length is from the vertex, how far the focus is. So if I call this point as focus, so what will be the coordinate of focus? Just try to understand. Tell me, what will be the coordinate of the focus? So focus is 1 unit away from the vertex. So focus coordinate will be simply what? 2, 1. 2, 1. Now another very important thing, what is the directrix of the parabola? Directrix of the parabola, what it will be? Directrix will be in the other side of the parabola and it will be 1 unit away from the vertex. So since focal length is 1, so directrix will be on the other side of the parabola, we know, and that is actually, if I consider this thing 1 unit away from this, that means we are lying on the y-axis. This is the origin of the small xy coordinate system. Focus is 1 unit away from this, so directrix is also 1 unit away in the back side, in the left side of the parabola. So what is that? This line is x equal to 1. So this line, it will be x equal to 0. So directrix will be this line. Is it okay? So focus is 1 unit away from the vertex. Vertex is 1, 1. Focus is 2, 1, as we discussed. And therefore, corresponding point, this point's coordinate, x coordinate will be 0 because it is 1 unit back left to the vertex. So directrix equation will be how much? X equal to 0. Okay, so directrix is x equal to 0. That means directrix is nothing but the original y-axis. This is the y-axis. So we have fully described the parabola. Parabola directrix is x equal to 0. Focus is 2, 1. Focal length unity. Axis of the parabola is y equal to 1. And vertex of the parabola is 1. All these are clear? Now, what do we do in this problem? Now, such type of problems, when you have to select a point on the parabola, because they have said any point P on the parabola, it is always better to take the parametric form of the point, parametric equation of the parabola. So, if you recall, the parabola equation is like y square equal to 4ax. Then what is the parametric form of parabola? You remember x equal to a square and y equal to 2a. But t is a variable. So any point 2at square lies on this parabola, because if you plug in y equal to 80 square, so what happens? Not 80 square, x equal to 80 square, so not like this. I have x equal to 80 square, y equal to 280. So any point having coordinate 80 square 280 must lie on this parabola. Why? Because if you just plug in y equal to 280, so 280 whole square is equal to 4a 80 square. So this side it is 480 square, 4a square t square, and this side it is also 4a square t square. So this point satisfies this equation. So this is the parametric form of the equation, parabolic equation. So 80 square to 80, where t is a variable, is always a point on this parabola, y square equal to 4x. That you have understood in regular parabola class. Okay, now in our case, what will happen? Our case a equal to 1, and our equation is like this. Our equation is like this. So what will be the parametric equation of this? It is a intelligent, you can make out intelligently how it will look like. So x will look like 80 square plus 1 A is 1, so it is t squared plus 1. And y, from just analogy, you can find out it is 280 plus 1. So this is the parametric form of x and y for this particular equation, because you just plug in here a is 1, so I should not use a separately, it is 2t plus 1. So just plug in 2t plus 1. So it is 2t plus 1 minus 1, that is 2t whole square, it is 4t square. Left hand side is 4t square. What I am doing, just plugging in y equal to 2t plus 1 in the left hand side of the equation. It is 2t plus 1 minus 1, so 2t whole square, it is 4t square. And RHS is what? 4t square. Again, t square plus 1 minus 1 multiplied by 4, it is 4t square. So LHS equal to RHS if I plug in x equal to t square plus 1, y equal to 2t plus 1. Therefore, what I can conclude that t square plus 1 and 2t plus 1 for a variable t always lies on this parabola. So what I do, the arbitrary point p, we can assume its coordinate to be, p is coordinate I can assume to be t square plus 1, 2t plus 1. So when you are handling problems with conic section, including circle, when you are supposed to take a point, arbitrary point on this curve, then always better to take a parametric form of the point, parametric coordinates. Here it is t square plus 1, 2t plus 1. This is a point, arbitrary point. T is a variable or parameter, and for any value of t, you get different points on the parabola. And this is an arbitrary point on the parabola. Had we taken a point x1, y1 on the parabola, if we take x1, y1 is an arbitrary point in this parabola, then you have to have a equation, have to have a relation like y1 minus 1 whole square equal to 4x1 minus 1. That equation has to be satisfied. But if I take parametric form, it is not necessary because it is already satisfied. I have chosen a point like this. That means the point automatically satisfies this equation, parabolic equation. So it is always better to take parametric form of the equation. Say, just let us recall circle's case. If you have a circle like x square plus y square equal to r square, so it is always better to consider a point r cos theta, r sin theta as a point on this circle, because this point always satisfies this equation, r square cos square theta plus r square sin square theta equal to r square. All these things we have explained in our regular coordinate geometry classes. So okay, so I take this point t square plus 1, 2t plus 1 as an arbitrary point on this parabola. So at any point p on the parabola, that point I take this. Okay, so up to this, any doubt? Now what we have to do? At any point p on the parabola, a tangent is drawn. Now, okay, let me select some other color of the pen. Say this one. So if I consider this point P, arbitrary point, this is an arbitrary point whose coordinate can be written like this: t square plus 1, 2t plus 1. Now, this is the point P. Now I am drawing a tangent at P to the parabola like this. Is it okay? This is the parabola. This is the tangent. And tangent, this yellow line is the tangent to the parabola, and the tangent which meets the directrix at Q. So here actually it is shown to be same point on axis. Let us just take the point at some other point. That will be convenient for understanding. So now I take an arbitrary point like P, like this P, and I draw a tangent to this, and let the tangent passes through the directrix at this point. So directrix is actually y-axis itself. So it cuts the directrix at this point. Okay, so they have said this point's name is Q because tangent is drawn which meets the directrix at Q. So we have already shown that x equal to 0 line is the directrix. So Q is the point where it cuts. So this is Q. Okay, now let us extend the tangent further, something like that. So this is the tangent line. Okay, now what is the equation of the tangent? What is the equation of the tangent? This is tangent line. What is the equation of the tangent? I am interested to find the equation of the tangent. How do we do that? So our equation is this, given parabolic equation is this. So from this I differentiate. So 2y minus 1 dy dx is equal to 4. If I differentiate this equation with respect to x, so 2y minus 1 dy dx equal to 4. Okay, there is no issue. Now dy dx is how much? 2 by y minus 1. But if I am interested to calculate the value of dy dx at the point P, P is this point where the tangent is drawn, and P's coordinate is this much. So what is the value of dy dx at P? So I just write dy dx equal to 2 by y minus 1, but y is actually 2t plus 1. So 2t plus 1 minus 1. Is it not? So it is how much? It is 1 by t. So dy dx at the point P is 1 by t. So this is the tangent whose dy dx at the point P. That means gradient of the tangent is 1 by t. And how t is there? T is related to P. The coordinate of P is t square plus 1, 2t plus 1. So what is the equation of the tangent? So equation of the tangent whose gradient is this much and passing through this point, it is easy to write. So y minus y1 is equal to 1 by t x minus t square minus 1. Okay, so it is cross multiply yt minus 2t square minus t equal to x minus t square minus 1. Okay, so it is from this I can write x minus yt minus t square minus 1 and then 2t square plus t equal to 0. So everything I have taken to the right hand side. So x minus yt minus t square minus 1 plus 2t square plus t. Is it okay? So it is how much? So if I just remove all these things, so equation of the parabola, equation of the tangent to the parabola at point P is how much? It is x minus yt plus t square plus t minus 1 equal to 0. X minus yt plus t square plus t minus 1 equal to 0. Okay, so this is the equation of the tangent. This tangent, yellow line. Now just look at the problem. What it is being said? A tangent is drawn which meets the directrix at Q. So it meets the directrix at Q. Now what is the coordinate of Q? My next question is, what is the coordinate of Q? So how do I find it? How do I find the coordinate of Q? Q is a point which lies on the directrix, and equation of directrix is x equal to 0. Okay, equation of directrix, this is the directrix which is actually x equal to 0. So for that, what I do, I just substitute x equal to 0 in this equation. Okay, so
It is a symmetrical.
so this no. So just what, let me recall what we have arrived so far. So the parabolic equation, parabolic drawing is like this. This is x-axis, this is x-axis, this is y-axis. Because this equation, just let me recall, y square minus 2y minus 4x plus 5 equal to 0. So it is y minus 1 whole square plus, it is not plus, minus 1 minus 4x plus 5 equal to 0, or y minus 1 whole square is equal to 4x minus 4, that is 4x minus 1. So y minus 1 whole square is equal to 4x minus 1. So the parabola we did looks like this is y equal to 1 line and this is x equal to 1 line, and the vertex of the parabola is here, and the parabola looks like this. It is symmetrical about this line, y equal to 1 line. And we have found the focal length of the parabola is 1, and the focus of the parabola is actually this thing. Just remember 2, 1. And vertex is 1, 1. And this line, y dash, that is x equal to 0, this is the directrix that we have already covered. Okay, and we have taken an arbitrary point P whose coordinate we have assumed to be what we have taken, because just recall y square equal to 4a has a coordinate, parametric coordinate is a t square 2at. So in this case, it will be t square plus 1 and 2t plus 1. So t square plus 1, 2t plus 1 satisfies this equation. 2t plus 1 minus 1 is 4t square, and here t square plus 1 if I substitute, then 4t square. So t square plus 1, 2t plus 1. And we have derived the equation of the tangent. Tangent looks like this. Tangent is like this. So tangent P, it cuts the directrix. This is the directrix. It cuts the directrix at Q. Okay. Now the equation of the tangent we derived, and it is actually x minus yt. We have already derived plus t square plus t minus 1 equal to 0. Okay, so up to this we did, then the board disappeared. So this is the thing. Now, where this tangent cuts the directrix, for that what we do? To find the coordinate of q, I substitute x equal to 0 or put x equal to 0 in this equation, because on this line x is 0. So if I plug in x equal to 0 over there, so it is yt becomes t squared plus t minus 1. So y is how much? T minus 1 by t plus 1. Okay, so coordinate of q is how much? So coordinate of p is this much, 1 plus t square, 1 plus 2t. This we started with this point. One plus t square, 1 plus 2t. This is the point E's coordinate. And Q's coordinate we have just found. Since it is lying on y-axis, so x coordinate is 0 definitely, and y coordinate is p minus 1 by 2 plus 1. Okay, now what we have to do? So these are no more required. So what is the next part of the problem? What is being said? We have to find the locus of a point R such that which divides QP externally in the ratio half is to 1. So R is such a point on this line, such that R divides QP a half is to 1 ratio. So RQ divided by RP, RQ divided by RP is 0.5 is to 1. That means 1.2. That means RQ is half of RP. RQ is half of RP. That means what? If RQ is half of RP, that means Q is midpoint of RP. Okay. Now R's coordinate, let me take HK. HK is a point on this tangent R, and since R divides QP externally in the ratio half is to 1, therefore Q must be the midpoint of RP, no doubt. So if this is R, HK, this is P, 1 plus t square, 1 plus 2t, and Q is 0 t minus 1 by t plus 1, then it is very simple to write the expression for H and K. How I can write the expression for H and K? So Q is the midpoint of RP. So what is H? H is H plus this divided by 2 is 0 in that case, since Q is the midpoint of RP. So what I can do? I can write, because I have to find the locus of R. That is the given problem. Na? So I can write H plus 1 plus t square divided by 2 is 0, because this is the x coordinate of Q is 0. So x1 plus x2 by 2 is 0. So I can write from this H equal to minus 1 plus t square. So minus t square is equal to H plus 1. You can write like this. If you take this, H plus 1 equal to minus t square. I can write this is one relation. Or better, I write H equal to minus 1 plus t square. Okay. Another is what? Y coordinate is what? T minus 1 by t plus 1 is equal to k plus 1 plus 2t divided by 2. There is no doubt because y1 plus y2 by 2. So k plus 1 plus 2t by 2 is equal to t minus 1 by t plus 1. So it is what? K by 2 plus half plus t. Okay. So I can write this t they cancel. So k by 2 I can write is equal to minus 1 by t plus 1 minus half. Is it okay? Calculation? So k by 2 is equal to minus 1 by t plus 1 minus half. So it is what? Minus 1 by t. Let me write over there. So k is minus 2 by t. Minus 2 by t. Here it is plus half into 2 is 1. So minus 2 by t. Here it is half into 2 is 1. So minus 2 by t plus 1. So k equal to minus 2 by t plus 1. So 2 minus 2 by t is equal to k minus 1. So minus 2 by t is k minus 1 and t square is minus t square is h plus 1. Now we have to find the locus of hk. So for that what we do? We try to eliminate t from these two equations. So what we do for that? So minus 2 by t is k minus 1. So I can write 4 by t square is equal to k minus 1 whole square. And 4 by t square, or I write t square is h plus 1. So 4 by minus h plus 1 is equal to k minus 1 whole square. Is it okay calculation? So 4 by t square from this is k minus 1 whole square, but t square is equal to minus h plus 1. So 4 by minus h plus 1 is equal to k minus 1 whole square. So what ultimately the t eliminant of this equation, that is after eliminating t from this equation, I get a relationship between h and k. What is that? Relationship is this much. So just if we write down, it is k minus 1 whole square into h plus 1 is equal to minus 4. Okay, or h plus 1 k minus 1 whole square plus 4 is equal to 0. So this is the relation between hk. Then what is the locus of hk? You know that this for determining the locus, I have to replace h by x and k by y. So x plus 1 into y minus 1 whole square plus 4 is equal to 0. It is the locus of R. So x plus 1 into y minus 1 whole square plus 4 is the locus of R. Okay, so you are asked to find the locus of R. Locus of R. So locus of R is x plus 1 into y minus 1 whole square plus 4 equal to 0. So this is the locus of the point. The problem is actually lot of things you have to do. You start from the given equation, you have to plot the parabola, and then you have to determine what is the directrix of this. And we found that this is y-axis is the directrix of this parabola, vertex is 1, 1, focus is 2, 1, because focal length of this parabola is unity. And then we have taken arbitrary point P on the parabola. Then you have drawn a tangent to parabola at the point P. Now, where the tangent cuts the directrix at Q, then you determine the coordinate of Q. Then R is such a point which divides PQ externally at R such that RQ by RP is half. Because they have said like this. So Q is the midpoint of P and R. If R is HK, then we could relate HK and T by these equations, and then we eliminated T from those equations, and finally obtained the locus of R like this. So this is the problem, and this problem appeared in one of the premier exam in India, top exam you can say. So here actually I don't say the problem is very tricky, but lot of things you have to do. You have to keep in mind it's a lengthy calculation apparently. So all these things, starting from drawing the parabola, evaluating the equation of the tangent to the parabola, and finally finding the locus. So such type of problems, if you want to handle, you need to be very patient and skillful in deriving all these results, and you should have a clear understanding on the geometrical structure of the graph. Okay, so I hope it was useful. So by this technique, we could evaluate the locus of R. Okay, so it requires a lot of patience. Okay, how you can solve the problem. It's a lengthy calculation. So I chose this problem from your feedback, and many of you could not solve this, but I think if you have patience, it is not difficult to solve such type of problems if you have clear understanding. So clarity on the subject is very much necessary. Okay, so now let us move to the next problem. Next problem is very interesting. It is, I would say, it is a very practical type problem. See what is happening. Show that an arbitrary light ray parallel to the axis of a parabolic reflector, after being reflected by the parabolic reflector, passes through the focus of the parabola. Parabolic reflector is a very practical thing you might have seen in towers, telephone exchange buildings, mobile towers. A lot of parabolic reflectors you might have seen. See, in few years back also, there were telephone exchanges, the big towers, if you recall, because there were towers like this, and there were reflectors like this. You remember, this is one telephone exchange building. This is another telephone exchange building, and adjacent to telephone exchange there are long towers, 60-meter towers, 80-meter towers, and on the top of the tower there you will find even today that such parabolic dishes are there. Okay, so actually at the parabolic dish means is parabola of revolution. It is a paraboloid structure. If you revolve parabola with respect to its axis, you get a three-dimensional structure like this. And at the focus of this parabola, there is a radiator, and it collimates the beam, and there is a line of sight communication between these two towers, these two nodes, telecommunication nodes. Okay, so basic thing is actually in a parabolic reflector, if a ray of light or a ray of electromagnetic energy comes parallel to the axis of the parabola, then after reflection it passes through the focus. And that is a wonderful property of parabola. That means it focuses the energy which is coming parallel to the axis of the parabola. So what is this? So this is a parabola, say for example, and this is the axis of the parabola. So if energy comes from infinite distance like this, all are parallel to the axis, then after reflection it gets focused at the focus of the parabola. So in the problem says that to verify really this happens in case of parabola, show that an arbitrary light ray parallel to the axis of the parabolic reflector, after being reflected by the parabolic reflector, passes through the focus of the parabola. So this problem is a very practical problem in the sense that what we use in our telecommunication systems, it may be reflector, optical reflector also, it can be a mirror. So if it is a mirror, a light rays are coming from infinite distance parallel to the axis. After being reflected, all gets focused at this point. So if you take a parabolic reflector, the energy will be focused at this point. If you keep a piece of paper over there, it will burn out. Okay. So it's a wonderful practical property of parabolic reflector, and we have to verify mathematically. Actually, it happens like that. So, do you find it interesting? It is very interesting. That means mathematics in real life, practical life, day-to-day life, you can say. So, what happens? Just I have taken a diagram for your understanding. Just I will show you. It is like this. So, it is a parabolic reflector. So, it is a parabolic reflector. If you take a vertical cross section of the paraboloid is with respect to this axis. If you rotate the parabola, you get a three-dimensional figure. If you take a vertical cross section of this parabola, it looks like this. And if the light rays come like that, then after reflection, they all get focused at F. So this problem asks you to verify this phenomenon. This is a physical phenomenon. And see, reflection is obeyed by Snell's law. You know. So it is a reflector sort of thing. Reflector I write like this. So Snell's law means angle of incidence is equal to angle of reflection. So angle I is equal to angle R. So at every point, if the light ray obeys Snell's law, that means angle of incidence is equal to angle of reflection, then all the reflected rays will pass through this point. So this is the problem. How do I do that? Now this parabola, this is a given parabola. If I choose a coordinate system like this, if I call this as y-axis, and if I call this as x-axis, if I call this origin, then origin coincides with the vertex of the parabola, and the equation of the parabola will be y square equal to 4ax, where focal length is a and coordinate of focus is a0. Coordinate of this is a0. So what is our task? Is that for any arbitrary ray parallel to the axis, this is the axis of the parabola whose equation is y equal to 0. Is it not? This equation of this parabola is y square equal to 4x, and this is vertex 0, 0, and this is the axis which is y equal to 0. So what we have to do, take any arbitrary ray parallel to axis, get the Snell's law obeyed at this point. P is the point where the ray strikes. After reflection, find the equation of the reflected ray and show that the reflected ray passes through this. If you can do that, then your job is done. You can solve the problem. So let us see how it can be done. So for that, let us take the following steps. So I take this parabola. This is x-axis, which happens to be the axis of the parabola also. This is the vertex of the parabola, which is nothing but the origin of the coordinate system. And equation of the parabola we are taking y square equal to 4x. Okay, and focus is obviously a0. Okay, now here you take an arbitrary point P. Again, you take the parametric form of this point. So P's form you can take as a t square 2a. coordinate of P you can take like this. No issue, because 80 square to 80, if I plug in 80 square over there, so right hand side becomes 4a square t square and left hand side becomes 280 whole square 4a square t square. So this point always satisfies this equation. So it is wise to take point P as 80 square to 80. Now, you take this ray, light ray, arbitrary light ray. So what is the equation of, so I call this an incident ray, IP. IP is the incident light ray. So what is the equation of incident light ray? Since it hits the point P, so therefore equation of the incident ray is actually y equal to 280. Because for all points on IP, y value is 280. Okay. Now, this is the normal. How I determine the normal at this point? Because for Snell's law, it is I equal to R. If this is the angle of incidence, then how do I calculate I? You have to take normal at this point P, and what is that incident ray makes? What angle the incident ray makes with this normal? If I call this normal as Pn, that you have to find out. Now, how do I find the equation of normal? Okay. Now, tangent. This is the tangent. You can say this is the tangent at this point. So y square equal to 4x. So 2y dy dx equal to 4a. So dy dx is 4a by 2y is 2a by y. So dy dx at the point P is how much? 2a by y. Y is actually 280. So 2a by 280 is equal to 1 by 2. So the gradient of the tangent drawn at point P is 1 by 2. So gradient of line PN, which is normal to the tangent, will be how much? It will be minus P, because MPN multiplied by dy dx P should be equal to minus 1. The tangent and normal, they are normal to each other, and therefore gradient of tangent and gradient of normal, if you take a product of them, it will be minus 1. Since dy dx is 1 by t, so MPN, which is the normal drawn to the point P, its gradient is minus P. Alright, then if, since its gradient is minus T, so this is the normal, just take, this is the P, point P, okay, this is the point P. So this angle and this is the N, I can say is a point on the normal, okay. So N is a point on the normal. This is the normal line. So I call this point as N. Now, what if theta is this angle? If theta is this angle, then tan theta is definitely minus T, because MPN is minus T. So theta is the inclination of normal with positive x-axis. So tan of theta must be equal to minus T. There is no doubt. This is the angle of incidence. Now Snell's law says that the reflected ray must pass through like this. Must obey Snell's law, and angle of reflection must again be equal to I. So if you extend the line, just remove the focus at this moment from the diagram. So if I just extend the reflected light, it goes like this. Okay. So what happens? So I call this point PR. PR is the reflected ray. PR is the reflected ray. Up to this is the incident ray, this is the normal angle. The reflect incident ray makes with normal is the angle of incidence. Angle of reflection as per Snell's law is again I, and I is this angle reflected ray makes with the normal. So if this is I, then what is this? If I call this angle alpha, the inclination of reflected ray with positive x-axis, if I call it alpha, then from this triangle you can easily write theta equal to I plus alpha. So alpha is how much? Theta minus I. Okay. Okay. Now what is theta and I? How theta and I are related? Let us see. So this angle is theta. This angle is I. This angle is also theta because these two lines are parallel. Ray of light is parallel to x-axis. So this angle is also theta. This angle. So I can write I is nothing but pi minus theta. I is equal to pi minus theta. Up to this there is no doubt because this angle is theta. So this angle is also theta, and this entire angle is pi. So pi minus theta is I. So this is pi minus theta is I. So alpha is how much? Alpha is theta minus I is pi minus theta. So it is what? 2 theta minus pi. So alpha is 2 theta minus pi. So what is alpha? Alpha is the inclination. Alpha is inclination of the reflected ray with respect to positive x-axis. So once the inclination of reflected ray is known, then what is the gradient of reflected ray? It's very simple. Gradient of reflected ray is tan of alpha. Tan of alpha. So what is tan of alpha? Alpha is this much. Alpha is this much. 2 theta minus pi. So tan of alpha is how much? Tan 2 theta minus pi. So it is minus tan pi minus 2 theta. Okay, pi minus 2 theta. Hope you are following this. So pi minus 2 theta is actually again minus tan 2 theta, and there is a negative sign, so ultimately it becomes tan 2 theta. So what is interesting, you see, the slope of the reflected ray becomes tan 2 theta. Tan 2 theta. Now, once you know the reflected ray gradient, which is tan 2 theta, then you can find the equation of the reflected ray. So how do I find the equation of the reflected ray? For that, what we do is tan 2 theta, I have written somewhere, tan 2 theta, this is the reflected ray. So tan 2 theta is the reflected ray's gradient. Then what is the equation of the reflected ray? Reflected ray actually emanates from the point P. It is reflected from the point P. So reflected ray definitely passes through point P. So equation of reflected ray, if I want to write, is how much? Equation of the reflected ray is y minus 280 y minus y1 equal to m. M is tan 2 theta x minus 8t square. Is it okay? So y minus 280 equal to tan 2 theta this thing. But theta, what we have found, just if you recall, this dy dx is actually y square equal to 4x. So from that I found that 2y dy dx equal to 2a. So dy dx is how much? So dy dx is 2a by t, because 2a by 2y is a by t, a by y, sorry, not a by t, is a by y, and y is actually 280. So dy dx is a by 2a t. So 2y dy dx is equal to, sorry, it is 4a. It is 4a. So dy dx is actually 2a by y. Dy dx is 2a by y is equal to 2a by 280. So it is 1 by t. So dy dx at p is 1 by t. Therefore, the MPN, we already derived this, again I am writing, is minus t. Because product of these two has to be minus 1. But MPN is therefore minus t. But if theta is the inclination of normal, then tan theta must be equal to minus t. So if tan theta is minus 1, so tan theta is minus t, then what is the value of tan 2 theta? Let us find out. Let us find out that. So we can rub this out. There is no need as such. So we are having an expression tan theta equal to minus t, and tan 2 theta is the gradient of the reflected ray. Is it not? So tan 2 theta is how much? So this much, let us so just let me draw once again. Why I am not able to select this thing?